Hello, friends. Wanted to take a quick break and just talk to you about the homework assignments. The feedback that I want to provide is the homework. Normally, it's going to be about an hour a day, and sometimes that's going to feel like a lot. Sometimes that's not going to feel so bad. But that hour, I don't expect everybody to get every answer of every question perfectly right. I provide you the answers, the solutions to the problems, just as a kind of a way to be like, okay, do you have a good feel about this or not? And also sometimes the back of the book or the even answers from the text, the instructor's guide, sometimes they help you have a deeper insight into how the problem is being worked. But I want to be clear. I've structured this class in such a way, and I've worked with our grader Rose on this to understand this. You don't have to be a mathematician or a math wizard, but I do expect you to do some work and expand your horizon some. And so let's explain what that means. Summarizing the question. This is something that you can look at it and you can write, you can look at the question that's given in the book and just kind of squint a little bit and be like, okay, what do I actually remember having read that? And sometimes you're going to remember, I think they want us to do something with numbers, right? And that's when you're having a hard time understanding it. Sometimes it's going to be we're looking for an inverse of the matrix, right? Or we're looking for some other specific item, and we can really have a good handle on it. It just resonates with us, but it won't every time. And so if your summary questions is, I think they want us to do something with numbers, and it's probably related to a sequence or a matrice or something like that, do your best and spend some effort. And sometimes I really think that's probably the part that you want to write the last. Just write a simple sentence that explains, hey, this is the crux of what we were doing here. The thing that I think you should do first, though, is come up with a list of references, right? And the reason you do that first is every time I read a question, my first response is, I have no idea. And then my second response is, wait, didn't I see something like that in the book? And so you just go flip back through the book a couple of pages and you're like, oh yeah, there's the definition. And I have a hard time learning things. And for me, the way that I work these problems, I learn it just long enough to write the answer down, and then everything gets flushed out of my brain. And I know I work that way. And so what I do is I just go and I grab the reference material that I need. So definitions, examples, all that stuff. I grab, dump it in that section. And then it's all in one spot. I don't have to thumb through the book. I don't have anything. It's all right there on my screen. And if things go sideways, I could print that off if I needed to, and I could see and work through it, have the references with me. I wouldn't have to carry the whole book. Usually the part that I do next is doing the actual work. And I know this might feel like a bit of a disconnect, but what happened to step one? Why don't we do it first? You don't do step one first because all it is a single sentence summary. And you really don't have a feel for that until after you've done the problem. I know in our brains, we're used to, start at the top of the page and work down. I wouldn't do that. And I know this is strange, but this is to help you have efficiency and improve your increased efficiency and improved performance. So first part I'd actually do is grab the references, and I just throw them all in one spot. So I've got them all together. I don't have to look for them. It's literally, grab them. Okay, ready to go. Second thing I do is try to work the problem. And it's one of those, this is an example of don't ever trust anybody that says all you've got to do is, because when they say all you got to do is, they're not you. And sometimes I would even go as far as to say, if somebody says, oh yeah, all you got to do is, maybe they haven't done it before or they haven't done it for a long time. And so the concept is you've got the definitions, you've got the examples, you've got the question copied down, you're ready to go. And then you start to do it. And it's like, oh my God. And you can't find anything, or the definition is like, this is for this case and this case. And you're like, yeah, but what about my case? And so the concept is, that's why we've got section 3. Section 3 was like, okay, the explanations didn't do a good job of explaining how to do this. The book didn't include this in the definition, or the example wasn't clear. Just kind of explaining why it is that you're making some of the assumptions or assertions that you're making. Assume that you're allowed to use negative numbers. Well, if you're not allowed to use negative numbers, then what can you do? Well, it actually just makes it easier sometimes to assume, yes, we're going to use negative numbers. Or sometimes you have to make other assumptions like a flying squirrel doesn't really fly. And I know that seems bizarre, a really strange and specific example, but the concept is, as you're working through a problem and you're learning these definitions, okay, as you're using these definitions to work through the problems and using these examples to follow, sometimes you're going to find holes in stuff. And then you're going to have to say, well, I had to just kind of make these assumptions to do it. The reason this is a necessary skill is if you're identifying assumptions and your assumptions are wrong, warning the other people on your team that you're making these assumptions, if they've got experience, if they've got information, if they've got other things that they can do, that enables them to have success and go in and help you. Okay. So the next thing that I wanted to talk about was how do you believe your answer? So the first thing you do is get your references. The second thing you do is actually work your problem. As you're working your problem, you're taking notes in part 3, which is assumptions and other observations. The last part 5, which is why do you believe your answer? Sometimes I think Javatric gave a great example. I followed the definitions and the math worked out the way that I expected it, and our answer happens to also match the back of the book. And that's just kind of a pretty good, everything just came together for Javatric and life was good. Sometimes it can be, I honestly don't believe my answer. I follow the definition. I know it matches the back of the book, but personally, I think, we should have done it, handled it this way. And I stated that in my assumptions. And so the concept is you don't have to be perfect. You don't have to be right. You don't have to agree with the book. You don't have to do all these things. The purpose of this class is to establish a problem-solving process. The process is have a summary of what it is you're trying to answer, have the references and resources that you're trying to use to solve the problem, have a list of assumptions that you had to make in order to go from the information you had to deal with the problem at hand. Finally, do a little bit of work to show how you get from the resources you have to your solution. And the last part is, now that you've done all that other work, why do you believe that you did it the right way? And I structured that way. If you really think about it, nowhere in there do I say you get majority of the points for finding the right answer. No, a majority of the points, 80%, no, I'm sorry. Yeah. 4 out of 5 parts have nothing to do with finding the actual answer. Four parts, the summary sentence and finding a list of references and making a list of assumptions and briefly discussing why you believe your answer. Whether your answer is right or not, it has zero bearing on those other 4 parts. The reason why I did that is because discrete structures is full of enough information. You really can get sideways on a problem and get to the point where you don't understand it. You may not have the background you need to have something. Your background might have presented the material in such a way that you can't get around to the problem that we're trying to work with here. And so the concept is there's a lot of reasons why things might go sideways. I don't want to punish you for that. And that's why I provided these other opportunities for points and other kind of hints and clues to help keep the process going. So does it add work? Yes. Should it add a whole bunch of work where every time there's a multi-part problem, you have like 5 extra things that you have to write? No. Basically, all of the steps are supposed to be there as a crutch for when the problems start to get challenging. Some of the things like the sequences, hopefully, it looked like a lot of people were having fun with the sequences. I know that was fun for me, and that's kind of why I picked the exam question that I did. But sometimes we're going to get into some harder questions, especially chapter 4, we get into big O notation, and it's a fun for a few people. For a lot of other people, it's like, okay, so the upward bound, and then this is lower bound, and everything falls in, but what does that mean, right? And so the concept is all the other things are there to support you in case you can't find the right answer. Now, if finding the right answer is easy to you, then perhaps this is an opportunity for you to work on your communication skills and communicate, okay, this is what you really needed to know. Here's what we had to assume, which really wasn't much. And here's the work. And this is why I believe it. And you can communicate those things effectively. But I do want to be clear. If you just want to work hard and you know that you're not strong necessarily in mathematics or programming or something like that, and you're worried, I am not the kind of faculty that says, here's the standard of excellence, and anyone that doesn't measure up to these exacting standards of measurement, I'm going to completely light you on fire and flunk you out of this program, and you don't get a. No, I am not that guy. I'm the kind of guy that says there's a lot of things that you need exposure to, and I want you to have the opportunity to see a lot of these different topics. But I don't want to use any one topic as a reason to say you're not going to graduate. Instead, I want to provide you lots of opportunities. So if you have one or two topics that are just beyond your scope, okay, we've got enough other opportunities. The other thing is, I really like I encourage my grader rows to hand out bonus points, because some of these students are going to do amazing things. And I encourage you to push the envelope. And if some of these problems resonate with you and you get really excited about it, and you want to be like, okay, so I see the example in the book. I don't care. I need to know. I want to go do this crazy other thing. Like, instead of doing a 3x3, what if we did like a 9x9? How's that going to work? Let's do it in code, right? Do something fun and exciting to you, something that resonates with you. I want you to get bonus points for that. I want you to have some fun. Now, there is one last thing that I want to talk about, and that is we're going to have the module summaries. This is the module show and tell. And the idea here is I want you to make a video. It can be a Zoom video, whatever. I don't want to get into the specifics, but the idea is if you had one problem that you were excited about, or one problem that you enjoyed more than the most, or even one that you hated more than most, I want you to take a little bit of time, and I want you to just make a video like this. And I want you to talk to me about, okay, we did this problem. This was cool. This was cool. This part hurt my head. Don't ever assign this problem again. This one sucked. Don't do this ever, right? Whatever you need to do, whatever you want to do, let's keep the conversation going. Let's keep the community going. And let's try to have a little bit of fun with this, whatever that means to you. Friends, if you need anything, do let me know. I do appreciate the emails. Hopefully I answered them to your satisfaction. Again, I want to reiterate, this is not a class where there's only one way to get an A and you have to memorize everything in the book. This is a class where we've got a lot of leeway, a lot of flexibility, and I want to reward you for your hard work. And your hard work the only way that you get credit for hard work isn't just finding the right answer. It's the process of solving the problem. And so I'm here to help. My grader Rose is excellent and is here to help. Whatever we can do to help you be successful, that's what we want to do. So hopefully the next set of homework goes a little faster for everybody. I appreciate all the hard work you did on the first one. I'm looking forward to looking at the exam. I appreciate y'all. Have a great day. If there's anything that I can do to help, please email me and let me know. Take care.